Hello and welcome to another live stream. It is again Sunday afternoon at 2 p.m. Welcome to everybody on YouTube. Thank you for joining me. Please like, comment and subscribe before you leave this video, and hopefully you'll make it to the end as well. And welcome to everybody on Patreon. Thank you so much for your support. So those on YouTube today, as is always the case, we'll get a quick lesson. I'm going to be going over the fundamentals of operations for fractions. So that's going to be adding, subtracting, multiplying and dividing. I'm then going to move on to a specific worksheet I've designed for this lesson, which will be exclusive to the Patreon viewers. So the YouTube video will end after we've gone through the tutorial. And then when we go into the part of the lesson where we work through the worksheet together, that will just be Patreon exclusive. Beyond that, I'm also going to be doing some work on algebra with fractions, so how it works with more advanced GCSE questions. So that will just be for the Patreon viewers as well. So stick around for that. Okay. So first things first, what I would like you all to do is to grab your pens and paper if you can. If you haven't got that in front of you, go and grab some if you've got it. If not, hopefully if you're using a computer, you might be able to open a Word document or some kind of word processing program while you're watching this so you can take some notes. It's going to be easier on paper though because we're writing fractions today. So I'm going to be writing fractions sometimes with my keyboard, sometimes with my pen, but it is easier to write fractions with your pen. So let's get into the first bit of the lesson, which is going to be running through the four main operations for fractions. So if you've got your notebooks ready, we're just going to have mixed operations with fractions as our title. If you want to put a date, today's date is the 23rd of March 2025, unless you're watching a recording, in which case you might want to, does not need to be capitalized, in which case you might want to write the date that you're doing it. The reason we write the date is so that we can keep track of when we've done what. So it's just a case of if all of your notes are together, if they're in date order, or if you specifically put the date, you can find when you did certain pieces of work, and then you can look at how they kind of filter into each other. So it's quite useful. Anyway, right, so we're going to start with adding fractions. We have that as our subheading. So we're going to start with adding fractions that have the same denominator. I'm going to assume some level of knowledge here before we begin. Some basics like knowing that the top number of a fraction is called the numerator and the bottom number of a fraction is called the denominator. So if we're looking at an addition with fractions that have the same denominator, we might have something like this. So let's say I have 3 over 5 plus 2 over 5. That's how I'm going to be writing my fractions for the most part. So it's kind of just a forward slash. Obviously, we know, don't we, that fractions normally look a bit more like this on top of each other. But just for the sake of ease and so that you can read my writing as much as possible, we're going to stick to these forward slashes for now. So when they have the same denominator, this is kind of the simplest operation that you'll have with fractions. It just means that we add the numerators together and the denominators remain the same. So in this case, we do 3 plus 2, which gives us 5, and the denominator is also 5. Now that just so happens to equal 1, because as we know, again, a little bit of an assumed knowledge there, any fraction that has the same numerator and denominator is always equal to the number 1. So that's just something to note. So 7/7 is 1, 86 is also 1. Okay, so let me just give you a couple of those. As we run through, I'm going to be just giving you an opportunity to answer some questions on your own before I quickly go through them. So I will pause at moments. So 4/9 plus 2/9. And then I'm also going to chuck in some subtractions here. Now the subtractions work in exactly the same way. So if I just do one example, let's say I had 8/10 minus 5/10. Because my denominators there are the same, I'm just doing a subtraction with the numerators. So I'm doing 8 take away 5, which gives us 3, and the denominator remains the same. So it'd be 3/10. So addition and subtraction are very similar. They work in exactly the same way. You obviously just got to remember to add or subtract depending on the question. Okay, so I'll just write a couple of those down as well. So 11/20ths, take away 6/20ths, and we'll also do 4/7 minus 1/7. So all of those there that don't have an answer yet, I'm just going to give you a minute or two, possibly just the 1 minute, to answer those, and then I'll quickly go through them before I move on. Okay, so let's quickly go through those. So we had 2/8 plus 1/8. So I just do the 2 plus 1, which gives me 3/8. 4/9 plus 2/9. I just do the 4 plus 2, which gives me 6/9. 11/20 minus 6/20, which is 11 minus 6, which gives us 5/20. And then 4/7 minus 1/7, which is 4 minus 1, which is 3. So it's 3/7. Okay. Now, occasionally, when you get a simple question like this, they will say something like answer and simplify. So, whereas 6/9 is not incorrect, that is the right answer. It's not the simplest version of that fraction. So we might just briefly go over how we simplify. I think we might have covered this last time that we had a math session when we were looking at converting between fractions, decimals, and percentages. When we converted to the fractions, we were simplifying. So again, there's a bit of assumed knowledge there. If you're not too sure of this, if I go through it too quickly, you can look back to a previous video just to clarify this. But essentially, to simplify a fraction, you can only simplify a fraction if the numerator and the denominator have at least one factor in common, a factor being a number that will divide into it. And so if they have a factor in common, you can divide them both by that factor, and the resultant numbers you get, top and bottom, will be the new fraction. So if I'm looking at 6/9, I know that they both 6 and 9 have a factor of 3. So I divide both of those by 3 to get a simpler fraction. So 6 divided by 3 is 2, and then 9 divided by 3 is 3. So 2/3 is the simplest version of that fraction. So I'm going to give you 30 seconds. I'm going to be really mean with this. Just want you to simplify any answers there that we've got that can be simplified. So they can't all be simplified, but some of them can. So look for the fractions that has a numerator and a denominator with common factors, and then divide them. If you divide it and then recognize that it can divide again, that means what you've not found is the highest common factor. So ideally, we're looking for the highest common factor, but it's fine to do it in stages. So as soon as you get to a stage where you can no longer divide them because they don't have any common factors, that means it's in its simplest form. So that would be where you stop. Okay, I'm just going to give you 30 seconds now. Okay, so let's have a quick look. 3/8 won't simplify. That's as far as it will go. 3/10 won't either. Nor 3/7. So actually, this was the only one. There you go. So 5/20 will simplify because 5 and 20 have a factor of 5. They can be divided by 5. So 5 divided by 5 is 1. And then 20 divided by 5 is 4. So it's 1/4. And that is the simplest form of that fraction. Okay, let's make it more difficult then. So if we want to make a note, perhaps, probably good to make notes as we go, to add or subtract fractions with the same denominator, simply add or subtract the numerators and leave the denominator the same. So if you want to just copy that down, that would be your first note. And I'm actually going to put that, I want to put that under my adding fractions section, don't I? I'm going to write the next note now, just explaining how we do it with different denominators. I'm going to add, I'm sorry, I'm adding to these notes in retrospect, so your notes may be a little bit messy, but apologies for that. We're going to actually put that adding and subtracting because we did it in one fell swoop. Okay, so as you copy that down, I'm just going to copy the next note down and then I'll explain it. So to add or subtract fractions with different denominators, you first must find two equivalent fractions that have the same denominators. You do this by scaling either fraction, either/both fractions up or down appropriately. To complete the question, you use the method. You then use the method from above. Okay, so I'm just going to give you a minute just to get those notes written down. It's useful to have those to look back on when you're doing your questions. Okay, right, so let's get into it then. So essentially, it's the same process once you've found your equivalent fractions. So as soon as you found equivalent fractions that do match denominators, you can do the same as what we did up here. But the task really here is to find those equivalents in the first place. So let's say I had 1/3 plus 4/9. So my issue here is that because my denominators don't match, I cannot just add my numerators. So what I need to do is I need to look at the denominators and I need to decide, how do I scale at least one of them up or down so that they match? So in this case, the first denominator, 3, is actually a factor of the second one, 9, which means the 9 doesn't have to change. I can just scale the 3 up, okay? Logically, you'd think, well, you could scale the 9 down, but actually, no, you can't, because you can't divide the 4 by 3 to get a whole number. So scaling up is normally the best way, unless the numbers match nicely. So scaling up is the most common thing to do. So we're going to change that 1/3 to be a fraction with 9 on the bottom. So in order to do that, in fact, what I might do is do this with my pen. So I know that this first fraction is now going to have 9 on the bottom. The second fraction is going to be the same, so it's going to be 4/9. So I'm scaling this one up. So what I need to do is just look at my scale factor. So what have I multiplied that 3 by to get to 9? And that would be 3. So in order for fractions to be equivalent, what you need to do is multiply the denominator and the numerator by the same scale factor. So that 1 on top of my third is also going to have to be multiplied by 3, which means that 3/9 is equivalent to 1/3. So my new question, which is technically the same question, we're just using equivalent fractions, is 3/9 plus 4/9. So now because the denominators match, I can just add those numerators together. So the answer is 7/9. Okay. I'll just do one more example and then I'll give you some to practice. I'll do a subtraction this time. So the subtraction is the same process. You've just got to find an equivalent fraction and then subtract as you normally would. So I'm going to say, let's make it different this time. Let's say I have 2/5, 3/5 rather. So I'm going to have 3/5 minus 1/4. Now my issue here is, unlike the first one, 5 and 4 are not factors of each other. So I can't just change one of them. I've actually got to change both of them. So if you're changing both fractions, what you're looking for is the lowest common multiple. Any common multiple will do, but obviously the lowest is going to be the easiest because it's going to be the smaller numbers. So the lowest common multiple between 5 and 4 is 20, which is what you get when you multiply them together. Some people prefer just to directly just go, okay, I'm going to multiply my denominators together and that will be my new denominator. And that actually, even though that can give you some really big numbers, you don't have to think too much about what the number's going to be if you just want to multiply them together. Okay, so in this case, it's 20 for both of them, okay? I've got to scale both of them up. So this 5 has become 20, and it's become 20 because I've multiplied it by 4. So you've got to think, what was my scale factor there? Which means that I've got to do the same for my numerator. So 3 times 4 gives me 12. Now this second fraction, because the denominator was different, it is a different scale factor. So 4 is actually multiplied by 5 to get to 20, which means that this 1 has to be multiplied by 5. So it's 5. So I end up with 12 minus 5, which gives me 7 again. So 7/20 is my final answer there. Okay. Right, I'm going to give you a few examples down here. I'll give you one addition and one subtraction, and then we'll move on. We won't spend too much time on it. We are going to spend more time on it with the Patreon crowd if you're on Patreon. If you are watching on YouTube, thank you for watching. Please like, comment, and subscribe. But also, my link to my Patreon will be in the description. So if you head down there, you will be able to watch this full recording as and when, because it's not just live. They're kept as recordings as well. Okay, so let's do 5/6 plus what should we do? 2/10. And then down here we're going to do 6/11 minus a half. Okay, so I'm going to give you a few minutes on your own, just have a go at that. Find your common factors, your common multiples, find a denominator that will be the same, work out your scale factors, and then work through the question. So I'll give you a few minutes and then I will go through it myself and show you what I would do. Do bear in mind, if you're watching a recording, which most of you will be, I'm assuming, just pause this and fast forward if I'm going too slow, or rewind if I'm going too quick. So use the fact it's a recording to your advantage. Okay, right, let's go through them. So, 5 6 plus 2/10. I'm going to say that 30 is the lowest common multiple. So both of these fractions are going to have 30 as their denominator. So 6 times 5 gives me 30, and 5 times 5 gives me 25. And then for this one, to get to 30, I need to times by 3, which means I times that 2 by 3, which gives me 6. So I've got 25 30ths plus 6 30ths, which actually gives me 31 30ths. Now, I can write that as a mixed number because that's actually 1 and 1/30 if I want to. That's fine as an answer unless specified otherwise. So if you're asked to give it as a mixed number, that would be what you need to do. And then finally, 6/11 minus 1/2. So we're going to go 22 on the bottom of both. So 11 times 2 gives me 22, and 6, I'm running out of space here. 6 times 2 is 12. 2 times 11 gives me 22, and then 1 times 11 is 11. So 11 22s minus, 12 22s take away 11 22s is 122. So that would be my answer there. Okay, cool. Right, now what I want to do is I'm going to have to get rid of some of that. I'm just going to give you a few seconds to copy any of that down. I'm going to move on to the next page, so I might have to delete some of this so I can move on. Yeah. Oh, it's not letting me do that. Okay, let's just get rid of it like this. Da, 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 da. So we're going to move on to multiplying fractions now, which actually, believe it or not, is easier. It's easier because we don't have to worry about denominators and equivalents. So next subheading is multiplying fractions. So I'll write a little explanation for you to copy and then I'll explain it a bit further. So to multiply two fractions, multiply the numerators together and the denominators. Okay, so essentially you're just multiplying across. So let's say, I'll do this with my pen again. Let's say I have 5/7 multiplied by 1/3. What I'm doing is just multiplying my numerators and my denominators. So I do 5 times 1, which is 5, and 7 times 3, which is 21. And that's it. That's my answer. So you deal with the numerators and the denominators separately and do them one at a time. So they don't kind of coincide with each other. Right, I'm going to give you a few of those then. So let's go on to the next page. I'm going to go beyond. Write it down here. Right, so I have 2/3 times 4/19. Do some awkward multiplications for you. 12/13 times 1/7. And lastly, 5/7 times 2/15. There we go. So just a couple of minutes and I'll go through those if you can have a go at those for me. Okay, right, let's have a look. So, 2 times 4 is 8. Remember, we're multiplying across. 3 times 19 is 57. Right, 12 times 1 is 12. 7 times 13 is 81. Now, this one can actually be simplified. I know I didn't ask you to do that. I'll get you to simplify that in a minute. Let's check this one. So 5 times 2 is 10. 15 times 7 is 105. So that one can also be simplified. This one can't. So I'm just going to give you a minute to try and simplify these two. You can remember how to do that. Keep that arrow, it's confusing things. So just have a go at simplifying those two. Okay, so remember, simplifying means that we're looking for common factors. So 12 and 81, I know they have a common factor of 3. So I'm going to divide them both by 3. So 12 divided by 3 is 4. 81 divided by 3 is, hang on, 27. And that's as far as it will go. 10 and 105 have a common factor of 5. So 10 divided by 5 is 2. And 105 divided by 5 is 21. And that's as far as that will go. Okay, lovely. Right, just going to give you a second to copy that down if you'd like to. And then we're going to look at dividing fractions. So I might write the dividing fractions up here, actually. So I'll just give you a second to copy that down if you want to. Okay, so last thing, dividing fractions. So the explanation, I'll write it down for you to copy as well. So to divide two fractions, you first need to find the reciprocal of the second fraction. In brackets, what the reciprocal actually means is to flip it. So the numerator becomes the denominator and the denominator becomes the numerator. It's kind of the opposite number. Then you treat the whole question like a multiplication. So once you've treated it like a multiplication, it works the same as multiplying fractions. So if you just get that copy down, and then I will give some examples of that. Okay, so again, I'm just going to delete some of these so I've got room. This is annoying, isn't it? There we go. Okay. So let's say I had 2/8 multiplied by 1/25. Okay. So my first thing is to take the second. Sorry, that's not the question, is it? It's divided by. That's what we're doing. I'm jumping ahead. I'm jumping the gun. So it's 2/8 divided by 1/25. Okay. So the first thing we need to do is take the second fraction and we need to write down its reciprocal, which means to flip it. So we then change the whole question into a multiplication. So it's going to be 2/8 because the first fraction remains the same, multiplied by now 25 over 1, which is 25, but we're going to keep it like that so that we can see how it works as a fraction. And now because we've made it a multiplication, we just multiply across as we did before. So we multiply the numerators together. So 2 times 25 is 50, and then 8 times 1 is 8. So we've got a top-heavy fraction here, which is fine. An improper fraction, if I turn that into a mixed number, that would be 6 and 2/8, which is the same as 6 and 1/4, because I simplified that 2/8 down. Okay. I'll do one more example and then I'll give you a couple to do on your own. So let's say I have 3/5 divided by 4/11. Okay. So I'll just do it here. First fraction remains the same. Turn it into a multiplication. Write the reciprocal of the second fraction and then treat it like a multiplication. So 3 times 11 is 33. 5 times 4 is 20. Again, we've got an improper fraction, which is fine. So that turns into 1 and 13/20. So we'll get into the habit of turning improper fractions into mixed number final answers. Okay, so I'll give you a couple on your own. So let's have 2/19 divided by 4/7, and we'll also have 11/15 divided by 2/5. Okay. So just a couple minutes on your own to have a go at that, and then I shall go through those as well. Okay, so right, so this one, 2/19 remains the same. Turns it into multiplication, becomes 7/4. 2 times 7 is 14. 19 times 4 is 76. I'm going to simplify that now. So that is going to be, I'm going to divide them both by 2 initially. So it's going to be 7/38. And that was as far as it will go. So 7/38. This is the final answer there. And then here we have 11/15 multiplied by 5/2. So 11 times 5 is 55. 15 times 2 is 30. So we've got an improper fraction here. So that's 1/25/30, which simplifies to 1 and 5/6 as a final answer. So I kind of whizzed through those simplifications there, but I feel like we will get in the hang of that anyway. Okay, so that is the end of the YouTube video. So if you're watching on YouTube, thank you very much. Please like, comment and subscribe. And if you want to watch the rest of this video, where we'll be going through a specially made worksheet for this lesson and some extra algebraic more complicated GCSE questions, then please join my Patreon. The link is in the description below. It's only £7 a month and you get one of these lessons every week, plus all of the worksheets will be available to you at any time. Okay, so thank you very much everyone on YouTube. I will see you again next week, where we'll be returning to English and we'll be looking at using figurative language.